I'm sure you're not gonna let me forget. I'm gonna get through this. It's a rough life, isn't it? Okay, so what I wanna do is I wanna review those steps again. I'm gonna go more quickly. Can you see it? You can't see me, but can you see the screen?
Yeah.
That's what matters the most, I think. You're faithful. Is it better to have it this way and see me, you think? No, it's fine.
I like it's fine.
Okay, good. So I'm gonna go through the steps again, but I'll do it more quickly, and then we'll finish the chapter. All right, so remember, steps of muscle contraction. The first thing that has to happen, nerve impulse. For any muscle contraction, the first thing is a nerve impulse. But of course, there's some sub-steps within there. The nerve gets to the end of the axon. Calcium channels open, calcium comes in. The neurotransmitter moves to the end of the axon and is released across the synapse. In the case of skeletal muscle, that neurotransmitter is always acetylcholine. So nerve impulse gets to the end, there's a synapse. Once the nerve impulse arrives, calcium channels open, calcium comes in. Acetylcholine moves to the end of the axon. Acetylcholine is released, crosses the synapse into the muscle. Then that nerve impulse travels deeper into the muscle, into the sarcoplasmic reticulum. Step number 3, the sarcoplasmic reticulum will release calcium. Step number 4, that calcium travels deeper into the muscle and it binds to a subunit on actin. Right? Step number 4, the calcium binds to a subunit on actin, causes a shift to expose the active sites. Now we can have cross-bridging, step number 5. Cross-bridging is when the head of the myosin binds to the active site on actin. There's no moving yet. Cross-bridging is when the head of the myosin binds to actin. Then and only then will the myosin head release stored energy and there'll be sliding, called the power stroke. But you see, right after that happens, myosin is pulled off of actin. So just as quickly as it cross-bridged and slid, now it releases. ATP pulls the myosin head off of actin. Cross-bridging, power stroke, release. However, as long as there are still nerve impulses coming down to the muscle, there will still be calcium coming down. So steps 5, 6, and 7 will repeat. As long as there are nerve impulses continuing to come down, there will continue to be calcium coming down. And the cycle of cross-bridge, power stroke, release continues. Cross-bridge, power stroke, release. Cross-bridge, power stroke, release. Each time, the myofilaments get closer and closer together. That cycle continues until there's no longer a nerve impulse. There's no longer a nerve impulse. There's no longer calcium. The actin and myosin will return to their resting position, and the sarcoplasmic reticulum will reclaim the calcium to store for next time. Yeah?
When is the time where there actually isn't nerve impulse? Because it seems like there's always some kind of action happening.
Well, like, isn't right now your big toe isn't moving, is it? So that's not moving. No nerve impulse there. So even though you're moving some parts of your body, other parts aren't moving. We're also going to talk about, when we get to the nervous system, there's always like a low level of nervous activity. So it's kind of like there's always a little bit of static in the airwaves, but we only generate a nerve impulse when we reach a certain threshold. So even though there might be, even if your toe is not moving, be a little activity in the nerve, just a little static background, but we're designed to only make an action potential when our brain wants us to when we reach a certain threshold. Each time we go through it, hopefully it gets in a little bit more and makes more sense. All right, so I want to show you some videos. Let's see here.
If you're taking anatomy and physiology for the first time, I can guarantee it's not like any course that you've ever taken. And that's why so many students struggle with it. What if I told you there's a secret study tool out there that you can use to help you ace your next anatomy exam? It's called
Secret study
Anatomy,
tool?
and it was created for students.
The secret study tool is me and you. So, you know,
Nerve
YouTube
impulses, also known as action potential.
YouTube has great examples, but sometimes there are videos that are too long or too detailed or not detailed enough. So I have given you 3 links that I think are reasonable for our level, right? They're posted on Blackboard. So this one I first pulled up is the neuromuscular junction. I think it's pretty good.
Potentials travel from the brain or spinal cord to trigger the contraction of skeletal muscles. An action potential propagates down a motor neuron to a skeletal muscle fiber. The site where a motor neuron excites a skeletal muscle fiber is called the neuromuscular junction. This junction is a chemical synapse consisting of the points of contact between the axon terminals of a motor neuron and the motor end plate of a skeletal muscle fiber.
So that you didn't need to know for me. I just like the visual here.
The
Oh, check
events
it
at
out.
a neuromuscular junction occur in 7 coordinated steps. Step 1. An action potential travels the length of the axon of a motor neuron to an axon terminal. Step 2. Voltage-gated calcium channels open and calcium ions diffuse into the terminal.
See, I'm not lying to you.
Step 3. Calcium entry causes synaptic vesicles to release acetylcholine via exocytosis. Step 4. Acetylcholine diffuses across the synaptic cleft and binds to acetylcholine receptors once the membrane potential reaches a threshold value.
So this
Neurons
gets
in the
more
synapse.
detailed than we got. But I just like the image, right? The visualization. Aren't you glad she's not your teacher? I think it was a computer, a visualization.
Sliding filament theory is the mechanism by which muscles are thought to contract at a cellular level. An understanding of the structure of skeletal muscle is useful when
Look at this picture, folks. It's great. Same thing we discovered. The whole muscle, the fascicle, the muscle fiber, the myofibril, the actin and myosin. Oh my
how
goodness.
sliding filament theory works. Each muscle is made up of a number of bundles of muscle fibers. Each bundle of muscle fibers contains anywhere from 10 and 100 individual fibers. Each muscle fiber itself contains cylindrical organelles known as myofibrils, which
What is that blue thing? The sleeve that covers the myofibril and stores calcium. What's that sleeve that covers the myofibril that stores calcium? Sarcoplasmic reticulum.
themselves are bundles of proteins called actin and myosin. Surrounding the myofibril, there is a network of tubules and channels called the sarcoplasmic reticulum, where calcium is stored. Each myofibril can be broken down into functional repeating segments called sarcomeres. If we look at a two-dimensional model of a sarcomere, it consists of actin
See?
and myosin.
See? Thick.
When a nerve impulse arrives at the muscle, it causes a release of a chemical called acetylcholine. The presence of acetylcholine causes depolarization, enabling
are not exposed, right? You don't see, remember that picture I showed you on actin? It had little, like, it looked like an olive pit. Right now, those active sites are covered. It's only when calcium comes down that this band will move to open the active sites. And only then can the myosin heads bind to it.
enabling calcium to be released from the sarcoplasmic reticulum. The calcium binds to troponin, changing its shape, and so moving tropomyosin from the active site of the actin. The myosin filaments can now attach to the actin, forming a cross bridge. The breakdown of ATP releases energy, which enables the myosin to pull the actin filaments inwards, contracting the muscle. This occurs along the entire length of every myofibril in the muscle cell. When an ATP molecule binds to the myosin head, the myosin detaches from the actin and the cross bridge is broken. When the ATP is then broken down, the myosin head can again attach to an actin binding site further along the actin filament and repeat the process. This repeated pulling
See how
of
it
the
kind of
actin
gets
over
closer
the
and
myosin
closer?
is often known as the ratchet mechanism. This process of muscular contraction
Every
can last
cycle
for as
gets
long as
closer
there are
and
adequate
closer
ATP
together.
and Ca+ stores. Once the nerve impulse stops, the Ca+ is pumped back to the sarcoplasmic reticulum, and the actin returns to its resting position, causing the muscle to lengthen and relax.
Alright. Helpful videos sometimes, not as good as me. Okay. It's okay, I'm gonna make it. Alright, good. You have enough to chew on there, don't you? Studying wise. So I just have a couple slides as reminders, okay? You know, there's so many ways you can talk about this. I was saying cross bridge, power stroke, release. Some people like bind. Binding is where it cross bridges. Bend is where it slides. Break is where it's pulled off again. And then at the end, it bounces back. Whatever works for you. Okay. So we've been spending all this time microscopically in the muscle. I'm down the wrong height, excuse me. We were spending all that time like microscopically in the muscle. Now I want to zoom out. So now we're zooming out and we're looking here. We're looking at how those nerves connect with the muscle fibers. I mentioned that the nerve endings have those tendrils, right? Right now, that's what we're looking at. We're looking at those endings of the nerve around the muscle fibers. We're not deep in the myofilaments. We're looking at those nerve endings. The nerve ending and the muscle operates together in what's called a motor unit. First of all, be able to define a motor unit. A motor unit is one motor nerve and all the muscle fibers that that nerve supplies. A motor unit is one nerve and all the muscle fibers it supplies. One nerve, and then however many muscle fibers those nerve endings go to. Here, in this picture, we can see a red motor unit. See the red one, number 2? And we can see a purple motor unit. So we're looking at the motor, we're looking at the nerve muscle unit. So let's look at the red motor unit. Each motor unit is one nerve, and then however many muscle fibers its tendrils supply. How many muscle fibers does that red nerve supply? How many? many muscle fibers does that red motor unit supply? Three, right? The red one goes to one muscle fiber, two muscle fibers, three muscle fibers. How many muscle fibers does the purple one supply? Two. So each motor unit is one nerve and however many muscle fibers it supplies. It's skeletal and cardiac. Cardiac's a little different. I'm trying to answer without getting too specific. Let's just say this is more of a skeletal muscle thing. It's a little different with the cardiac muscle. But this is efficient. Can you imagine if we had to have a ratio of 1 to 1? Wouldn't that be really inefficient if we had to have one nerve